We're live. This is Math 60 Intermediate Algebra, and we're at a very exciting section. Exciting being a code word for make sure you have your support folks, support animals, support stuffed animals, support socks, maybe your support Snuggie with you, because this is quadratic inequalities, and they are exciting and strange and weird, and they will make you doubt that you actually understand math. But the good news is I will show you how to understand them. And it's just, this is probably the first time we're really going to get into a topic where you can't solve it the way you think you should be able to solve it. And I will show you why. Okay, so let's start off with an inequality. Right? If quadratic inequalities are what we're doing, I'm going to start out with what we call a linear inequality. And we've already worked with these, right? These were a long time ago in the class. If I have x minus 4 is less than 0, I've got x to the first power. That makes it linear. I'm going to go ahead and add 4 to both sides. You're always allowed to add numbers to both sides of an equation or an inequality. I'll remind you that I made a strange little video, and I'm trying to remember, it was like the Hulk and Loki, and you're allowed to add both sides because they could both be up on a box. You can go back and look at that video if you're unsure about it. So I've got x on the left and less than 4 on the right. And so I've got a couple ways I can give my answer. I can give my answer as an inequality. X should be less than 4. I could give it as a graph. And we talked about it in my class. I like 2 numbers, usually 0, and then whatever this number is, which we're going to start calling the critical value. And we want to be less than that. So I'm going to go like this. And, rather than just scribbling, I'll go ahead and write it in with my purple pen. There we go. Hopefully I didn't take you to Smeary Town too much. And then also there's an interval that's associated with this, which is the interval from -infinity to 4. So easy peasy, hopefully. So that's not quadratic inequality, though. That's a linear inequality. This is a quadratic inequality. And so the question is, can we solve this the same way? Let's try. So we add 4 to both sides, which is totally legal. Nothing done wrong here. But then we've got a situation where I've got, and here's my little squirrel. See how happy the squirrel is? Don't panic. No panicking. There's a happy squirrel there. X squared is less than 4. And then I'm kind of stuck. Now you might think, well, maybe I could do something weird with square rooting. Right? Try square root. Let's try square roots. Why not? So x is less than 2. Okay, so if x is less than 2, let's see, on my graph, that would be everything smaller than 2. Okay. So let's try a couple values. So if I try a value, let's see, 1 is in that interval. So if I try x equals 1, 1 squared minus 4, is that less than 0? 1 minus 4, yeah, that's -3. That's less than 0. Oh my gosh, I'm feeling so good about this solution. What are some other numbers that are less than 2? Well, another number that's less than 2 is -3. Let's try that one. So -3, the quantity squared, minus 4, is that less than 0? And that's 9 minus 4, which is 5, which is greater than 0. Uh-oh. So taking the square root of both sides gave us maybe some good answers. But then at some point, if you keep going to the left, then you're going to come up against numbers that get too big because we're squaring them. And that's what the difference is. In a linear inequality, negative numbers stay negative. So if I plugged in Let's see, let's check x equals -3 like we did before. I get -3 minus 4 is less than 0. Yeah, that's -7. Yeah, it's totally less than 0. So when we plug in a number like -3, it stays negative. Then, much like the pet cemetery, if we have a quadratic inequality, negative numbers do not stay negative. They come back up and be positive, and then they haunt you in your dreams. So I'm not going to say that quadratic inequalities will chew off your arm when you're sleeping, but I would maybe lock the door. So this totally didn't work. Does not work. So now that I've crushed your dreams, let's go in and I'm going to show you how to deal with it. And basically, the big part, I know I keep shifting it up and down. It's very exciting. That's what happens when you have more than one cup of coffee in the morning. More than one cup of coffee in the morning. The big thing that happens is because in a quadratic, you're going to be squaring x. That means that negative numbers don't stay negative. You actually square them and you get a positive result. So there's more than just one. Like up here, there's just 1.4, and you're either less than or greater than. When we actually do quadratics, we're going to have, yes, it needs to be less than 2, but then there's a point at which it kind of flips back, and we have to stop. Please tell me I set this up. Oh, good. It's all set up. I was worried I changed the equation. So I want to go ahead and approach the exact same inequality. And let's talk through the steps. Now, the bad news is this is probably, if you've never taken this algebra before, this is going to be weird and different and a complete surprise. The good news is this is the foundation of a whole set of solutions. So this isn't just learning this one little weird case in 8.5. If you go on in math, in engineering, in physics, in sciences or math or architecture, all those wonderful computer science, you're going to find that the technique we're using here with critical values is going to come up all the time. And in fact, it's going to come up. What we're going to be practicing right now is something that we'll be using in calculus even. So let's see if I can quickly do this. I'm setting my camera so it doesn't beep anymore. Okay, so are we all ready? Do you have a nice yummy drink? Do you have your support system in place? Do you have your Snuggies on? Okay, let's do it. Warm socks, whatever it is. Cold socks, if that's what you prefer. Your coffee. Sadly, my coffee is almost gone, but we could always get more coffee. Okay, so we're going to solve the related quadratic equation. So what's the related quadratic equation? Well, if I have x squared minus 4 is less than 0, then I'm going to solve the equation x squared minus 4 equals 0. And you've got a couple ways to solve this. You could use the quadratic formula. You can use factoring. I'm going to use factoring because I think it helps to show us what's actually going on. So I really like the factoring. So I'm going to factor it. X squared minus 4 is a difference of 2 squares. So I get x plus 2, x minus 2 equals 0. And then remember this step. This is a hard step to remember. People say, oh, I'm done. Then you do x plus 2 equals 0, which means x equals -2, or x minus 2 equals 0. Now, the nice thing about this is because this is equals 0, we don't have to worry about if we're multiplying or dividing or flipping inequalities up, over, and backwards and sideways. So that's why we switch it from the inequality to the equality, because then we have the critical numbers or the critical values. Okay, so those are the critical values. Now, what makes them critical? Well, if you plug in -2, -2, the quantity squared is 4, minus 4, equals 0. So it's right at the tipping point. It's not less than 0, it's not bigger than 0. It's right at the tipping point. X equals 2, 2 squared is 4, minus 4 equals 0. So we found that right in the middle point, and that's what we want to find. So that's our boundary numbers or our critical numbers or values. Okay. This is the part where things get kind of weird. So I want to, on another piece of paper, so let me get one of my magical pieces of paper. Let me draw part of a graph. There's my Y. Here's my X. And I am going to ask you a logic question. In fact, let me turn this over so it doesn't get too distracting. And the logic question is this. If I have a point up here, and if I have a point down here, and I connect them, do I have to go through the x-axis? And the answer is yeah. Even if it's not a function, even if you allow it to go wherever you want, which we're working with functions, but let's say we weren't even working with functions, we're allowed to go anywhere. You can do curly cues, you can go around. The thing is no matter where you go, you have to get from this point to this point, you have to go through the x-axis. So there has to be a point where the function y equals 0. Or this isn't a function, sorry, the equation has to equal 0. The expression has to equal 0. So no matter how you get there to get from here to here, you have to go through 0 first. Okay, second question. If I tell you that there is a point here and there's a point here, if those are our only two zeros, and I know that in this interval, there's a point right here, I'm given that point, and this point, there's a point down here, and right here, there's a point right here, let's say. Okay, so let's say I've got these. Okay, now hopefully your mind is already drawing a parabola. It's going, ooh, it's a parabola. It's not quite, but it looks a little like it. Could, if these are my only two zeros, could this go down and back up again and do a bunch of wiggles like that? It can't. Why not? Because then there'd be another 0 there. So what we know has to happen, let me use pink. This has to stay up above 0 until that point. And then, I mean, it can dip around and it can do lots of interesting things. But between these 2 points, if these are the only two zeros, it has to stay down below. So if, back to this page, if I know where the expression equals 0, it equals 0 at those 2 points. So just an x-axis to make things easier. I've got -2 and I've got +2. And I know it equals 0 here, and I know it equals 0 there. If I pick a point in here between -2 and 2, so any point in there, you could say -1, you could say 0, you could say 1. If you wanted to, you could say 7/48. I don't know why you would, but you could. I'm gonna go ahead and pick the number 0. Okay. So if I pick the number 0, any number in between here, and I plug it in to the expression x squared minus 4, so this would be 0 squared minus 4. 0 squared minus 4 is 0 minus 4, which equals negative 4. So that's negative. Then I know that for this whole interval, let me use yellow. I'm going to go to Smeary Town, unfortunately. I'm trying not to be too smeary. For that whole interval between -2 and 2, this is negative. And again, you should ask, wait a minute, you only checked 1 point. How do you know all the points are negative? And I said, well, I've got a 0 here, and I've got a 0 here. So if 1 point is negative, they all have to be negative. Because for it to go negative and then positive, it would have to have another 0 in here. Since there's no 0 in here, the whole thing is negative. So this is what testing an interval is. You pick one value in between, your choice. So I got to pick over here. I'm going to take this interval, let it be green. I pick 1 point. Now, if you read the book, you'll see they have a slightly different way of setting up the chart. You can set up your chart however you like. I'm going to pick the point 3. So I'm going to test 3 squared minus 4. So that's 9 minus 4. That equals 5. That's positive. This is positive. So this whole interval from 2 arrow, because these are the only 2 zeros, this whole thing is going to be positive over here. Okay. And let's go to, let's see, I haven't used pink yet. Let me use pink. Let's go to this interval over here. I need to pick a number that's less than -2. And again, if you want to choose negative pi, go for it. If you want to choose -1,000,000, go for it. I'm going to choose -4. Why not? Just for the heck of it. I could have chosen -3 and saved myself some time, but I'm just picking random. So these, you pick the test numbers. Okay, you pick these test numbers. It's up to you. So here I've got -4, the quantity squared, minus 4. Right? I'm following this. I'm following, oops, you can't quite see. Up here, I'm following the left-hand side, the expression that's either less than 0 or greater than 0. And so -4, the quantity squared, is 16, minus 4 is 12. This is positive, positive. Okay. So what have we done? We solved the equality. We set it equal to 0. We found our critical numbers or our values. We set up a chart. We picked test numbers. I figured out whether the test numbers were positive or negative. Now let's look up here and we can see if it's less than 0, we want negative values. So from -2 all the way to +2 in the yellow section, that is where we get negative. Tell me about the green portion. In the green portion, this gives us a positive value on this side. So this would, in this section, x squared minus 4 is greater than 0. It's positive. Over here, x squared minus 4 is greater than 0. In here, x squared minus 4 is less than 0. That's what we want. So what's the solution set? The solution set is the yellow set. -2 to 2. Now it's exclusive because these two are the places where it equals 0. Notice we don't want to let it be equal to 0. We just want less than 0. Okay, so that interval is good. And then we can also draw it as a graph. It's this section in the middle. Now let's go back to the first page for a moment. Notice that when we tried square roots, we weren't completely wrong. We got x is less than 2, which is part of it. But because of the quadratic nature, you notice when I tried out -3, which is not, I should have tried -3 there. Okay, I have regrets. I have regrets. But, you know, Water under the bridge. So when we tried x equals -3, it did not work. Why is that? Because we have to limit it to between -2 and +2. So this is the method. And this method is going to be something you will use, well, with all the problems we're going to do in this section, plus calculus. This will be, you'll be using this in calculus over and over and over and over and over and over again. Okay, so since these problems are a little bit on the longish side, I think I'm going to stop this here with this video, and I will continue on. There are a couple more problems I want to give you some practice with, and we'll be doing quadratics, and then we'll be doing a little bit of rational expressions too, because I think it's good practice. And that's it. Woohoo. Okay, you guys are awesome. Math on.